So hello, everyone. Welcome to my talk about advanced Kotlin native integration. I wanted to call it weird Kotlin native integration, but it didn't feel appropriate for Kotlin Conf. I might still do that for the other conferences. My name is Tadeas Kriz. I'm a mobile developer at TouchLab. I've been dealing with a lot of weird stuff around Kotlin compiler, Kotlin native integration with iOS, and I'm also one of the co-creators of Sky. Quick show of hands before we begin. How many of you are using KMP? Perfect. How many of you are iOS developers? Oh, wow. That's beautiful. How many of you were Android developers before you became iOS developers? OK, cool. So for all of the iOS developers, you're the only ones who should stay. This will be a talk geared primarily towards iOS. Because KMP for Android is just Kotlin for Android, right? Like, there are some differences, sure, but overall, it's the same thing. It's the iOS team that has to deal with the brunt of the weirdness of KMP. The topic of this talk is coming from a larger project that I worked on. And it might not apply to everyone. And it, again, might be super weird. So bear with me. We'll begin with an iOS app. So a lifecycle of a very small and awesome app, purely native, all Swift, no KMP. As time goes on, the team starts modularizing the app. They add 2 modules, A and B. And as time progresses some more, they modularize more. They have some frameworks that are shared between their other frameworks and have some shared logic. I intentionally went with just placeholder names, because we will only have these 3 frameworks. And it doesn't matter what frameworks they are. It's all about the structure. We have an app. That's our final executable. Then we have some intermediate frameworks that are in parallel. And then we have a framework, the C framework, which is our common code that is shared amongst those 2. Now, someone on the Android team came to the iOS team and was like, hey, we have this super cool thing where you don't have to write as much code, and we can share everything. What do you think of that? And the iOS team is probably like, no, thank you. And you're like, pretty please. OK, sure. Let's do something small. So you start with maybe some enhancing of one of your framework in the iOS. So you have very little in the shared framework. You don't do much, because you need to first test everything. But as time goes on, maybe the iOS team likes it, and you keep adding. And in the end, assuming that you modularized your KMP framework, which you should, you may end up in a situation similar to this one. The iOS team still have their A, B, and C. That might be like your login, some kind of utils, UI stuff. But they are more and more using your shared KMP framework. But on the KMP, we also have the same modules. We have our authorization, authentication, some kind of services domain. So we have the ABC on the KMP side, and we have the ABC on the native side. But everything is going through the same single shared framework. A quick sidestep. What is a framework? For our purposes, we'll simplify it to just being a header or some kind of an interface and a binary or some kind of an implementation. It's just a fancy directory anyway, with a structure that you should follow. So don't really worry about what the framework is. What is important for us? Again, an interface and an implementation. Compared to a KMP framework, this still holds true. But in regular frameworks, you usually have multiple headers, and then one umbrella header that ties them all together. But with KMP, we have just one, with all of the stuff that we want to expose. And our implementation, the binary, contains all of our KMP code, all of the modules, and bridges, and Kotlin standard library, and the runtime. One big difference is you should always have a single KMP framework. You should never have multiple KMP frameworks in your app. I will repeat that. Do not use multiple KMP frameworks. And before you hit me with like, why shouldn't you? Let me tell you. The obvious one is larger binary size, right? So whenever you have multiple KMP frameworks, the standard library, the Kotlin native runtime, they both need to be included in all of them. So there's larger binary size just because of these. But if you also have some dependencies, like our C framework here, all of that C module code is now in all of them. But that's not everything that's bad with it. If it was only binary size, I think we all could live with it. The internet is fast now. We have devices with a lot of storage, even though AI is making that increasingly difficult and expensive. But it's also limiting you to only dynamic linking. The reason for that is, in this scenario, those frameworks are dynamic. And when you put the app together, the linker for the app adds load commands into the app binary, which says load A, load B, and then the whole app bundle embeds those framework into itself. With static linking, what the linker does is it takes all of those symbols, all of the binary, and puts it into the app binary. So it does that with the standard library, does that with the Kotlin native runtime, a module code, and then discards the framework. The framework's no longer needed. But then when it comes time to take the things from the B framework, we get to an issue. Hopefully that would happen in compile time, but usually it happens in runtime, where your results can range from undefined behavior to crashes, and you don't want to be doing that. Thankfully, the Kotlin native team has implemented some guardrails. So when you do this, sometimes the app will crash right away and tell you, hey, you're not supposed to do this. You're not supposed to have two static frameworks. I've seen it sometimes not happen, and instead it would be like, oh, the app starts, and then the weirdness happens. So if you only test by running the app, it might be like, everything's fine. Then we have the problem with incompatible types. So each of those frameworks, so B and A, they depend on our C framework, and the C framework is providing the class C. But we can't just do this. We can't call consume C produce C. And the reason for that is that the C in A is actually AC, the C in B is actually BC, and vice versa, it's C squared for the C framework. So from the point of view of the native code, all of those are separate. They live in different memory. They can be just interused. So you're basically like, if you need your code to interact, it just won't be able to. And unless you build some weird bridges, not recommended. The one thing that's less talked about, and I have been kind of like missing it myself for the longest time, is that it also leads to higher memory and CPU usage. One, the larger binary size, that all needs to be loaded into memory anyway. So one, you load all of that into memory. That's kind of expected. But then every single one of those frameworks also need to allocate a block of memory for the garbage collector heap. And also, it needs to have 2 threads for the garbage collection to be like kept in check and everything. And so all of those threads, they work independently and mean that, like, even though you probably, if you split your code this way into multiple frameworks, every single of them is probably doing less than if you had one umbrella. But the overhead of switching between all those threads and doing all of that work, that's something that you will just lose on. With the heap, there's another issue, is memory fragmentation. So what can happen is, if your heap grows to a certain size and needs to be made bigger, if your memory is fragmented enough, the system might take a long time to move all the memory around to defragment it and allocate the heap for you. And sometimes it can just kill your app if it can't do that. Lastly, this is something I haven't been able to reproduce in a small project yet. So this might not be a Kotlin native thing, but all the stack traces point towards it. Essentially, when you have Kotlin native code and you call it from Swift code, any thread that you call it from will be marked by the Kotlin native runtime as, hey, I've been running in here. And then the garbage collector may actually pause all of the threads from time to time to do the stop the world garbage collection. This can lead to a deadlock where imagine you have two threads for simplicity, and we have two frameworks. So we sometime in the app, we access both of those frameworks code from both of those threads. And then at some future time, both of the garbage collectors decide to do this stop the world garbage collection at the same time. And when they do, we call one of the frameworks from one of the threads, the other framework from the other thread. But because it wants to do this stop the world thing, it will pause, the framework A will pause the thread 1, framework B will pause the thread 2, and we just have a deadlock because they are waiting for the other thread to call them, which will never happen. However, single KMP framework ain't no sunshine and rainbows either. You have all of your things, all of your exposed classes in a single namespace. So when the Swift people import it on a bigger project, that's a lot of stuff. But it also creates this single choke point that we've already seen in the dependency graph, where everything needs to go through this single umbrella. Everything needs to build first before we can continue building the native code. That limits incremental compilation as well as parallel compilation. To illustrate what I mean by the incremental compilation being limited is, let's say we have just a native app. We make changes in A, and when we do that, only A and the app itself needs to recompile. The rest stays the same, and we just bundle it. With KMP, if we change A, shared recompiles, C recompiles, AB recompile, and then the app recompiles. Every single time, even though we just made changes into A. For parallel compilation limitations, this is similar, but the difference is essentially, right now, if we start make any changes in C and run the compilation, we have 3 compilation points essentially, right? Like we have the one where we compile C, and we have one where we compile A and B, and then one where we compile the app itself. With KMP again, we can do that, because we first need to compile all of the KMP, only to start compiling the shared. Then we compile C, then A and B, and then the awesome app. So we made the whole pipeline longer, because we always add to the beginning of it. So how about we explore the multiple frameworks some more? There has to be a way, right? We said that this is limiting. It limits the incremental compilation, and the parallel compilation takes forever to compile, but is the correct one. And then this one we just don't want to use ever. What if I told you there is another way that combines the two into one? And that is building dummy frameworks from all of the modules. And they are called the same way. So I already see this face. So, as I said, this is the weird Kotlin native integration. The reason why all of this works is how native compiles things and links things. When it comes to the compilation of native, we start with some dependencies. We don't care what those dependencies are. We just care about the headers or some kind of interface. Then we go and compile our compilation unit, which here, foo.c, into an object file. This object file only holds references to the external symbols as like, hey, at some point I will need this from somewhere. And then it comes to the linking. If it's a static linking, we don't care. That's just the object files. We bundle them into something we call a static library, and we're done. If it's dynamic, it does require the dummy binary. But our dummy binary has all the symbols that we need to use. So what is a dummy framework? We essentially just declare a regular KMP framework in Gradle. We use the link task. We cannot use the embed task. And we put an absolute path to that binary inside the framework, to other LD flags in the native code. And then we need to put absolute path to the framework's parent, to the other Swift flags of the native code that we'll be building. And again, make sure not to embed this. This dummy framework is something that we discard. We build it, we compile and link against it, and then we no longer cares. So let's take a look at how this works. I've built the same thing, ABC, in this sample. And we have the umbrella that builds the final framework for us. But our A, B, and C are just regular Kotlin multi-platform code. It can be common main, can be iOS main, whatever you want. The main difference comes where we look at how the umbrella produces the framework. So in here, we produce framework for these two architectures. It's called shared Git. In our case, it's dynamic. It can be static. It's fine. Either works. You just need to make sure that when you're building the native code, you're building it the same way. Because if you decided to make your native libraries dynamic, they would bundle all of that code from the static KMP dummy library, and we don't want that. And then we use the export to make all of our things available from the framework. So this is normal, right? Like you probably have that in your projects. But then we also declare the same frameworks in each and every of these modules. So we have one for A, we have one for B, we have one for C. We need to export our dependencies that we want to be available. So in this case, we export the C. And we are also exposing all the public declarations inside of this module. So if we switch to Xcode itself, in here, all of our code is split into 4 targets. We have the native A, native B, native C. So these are our respective frameworks that we've seen in the slides. And then we have the app itself that puts everything together and bundles it. In the native code, we just use the KMP as we would. So we have import shared Git, and we can just use it the way we would use any other code from KMP. Nothing weird so far, right? In here, in the app itself, this is where I call those functions from the native A, B, and C. So we have consume, right? So it takes the consumer from the shared Git, calls consume, we do some things. This sample is super stupid. Don't worry about it. That's not the reason we're here. The reason we're here is when we actually run it, it takes forever to build. We made everything worse. Good luck. Everyone can go home and think about your choices. So we have super important complex app. We hit click me and it logs, hello, I am A, change in native A, change in app, change in native B. Again, this sample doesn't make any sense. Doesn't need to. What's important here is every single one of these targets, they have their own build Kotlin multiplatform phase where they run the link phase. It's not visible here, but this is the link task, right? So like we would do link iOS ARM64 debug. And then we point to it, as I mentioned we have the other LD flags. So we say dash framework, and then point it to the binary itself. And then in the other Swift flags, we give it a dash f and where the framework lives. This is enough that we can use everything here from, so we're in native A now, and we can use unused public class in A. So that's one of the classes that I've put into A. And we can also use unused public class in C. That's the one that's coming from the C KMP module. As you can see, like, we don't see anything from B, because we are not actually, like, we don't have access to the whole thing here. With that said, this seems like a total waste of time, of everyone included, because we're building 3 more frameworks. Yay us. But the use case isn't for this monorepo project where everything is inside one project and we're just like trying to play around with things that are possible that don't make sense. This is best used for large projects, especially if they are heavy on Swift code or Objective-C code that is using our KMP. And it does require an already modular project or one that can be modularized. Okay. The reason for all of this is when you have a project like this, it's difficult to find a good setup for multiple repositories. Because you can either put everything into one monorepo, and that is one way to do it. But once your project scales and is large enough, it's going to be a problem, one way or another. And you may be like, OK, like, we need to put things apart. But how? This approach allows per module repositories or per feature repositories, where we can have separate repositories per our features or different modules. Here we would have repositories A, B, and C. And those repositories would produce klibs for the Kotlin native code and frameworks, build frameworks of the Swift code or Objective-C code. And then at the end, you pull everything together into an umbrella framework. The Kotlin native, all the klibs are pulled into an umbrella framework. And that's integrated with the app itself. And all of those frameworks that you've already built are also integrated. What's good about this is when we now change something in A, we don't have to recompile C and B. We are only rebuilding the A klib and A framework, and then the umbrella framework and the app itself at the end. And if the umbrella framework is not doing anything and just pulling everything together as it should, and the app itself is doing the same thing, it greatly reduces the amount of like changes and the impact of your changes. But this still seems like it would be too slow, because we are making all those compilations, which is why we can do more. We can actually save a static cache that is produced by the Kotlin native compiler. So when the Kotlin native compiler compiles your Kotlin code, it first compiles the klibs, and then those klibs get compiled into object files. If those object files come from a library, those are cached statically, and so that every time you do an incremental compilation, it's way faster than your clean compilation, because it's reusing those object files. Compiling those object files is what takes most of the time. And we can actually save these as long as we're using the same Kotlin version everywhere. That's one important caveat. But that's something that you can usually make sure that that's the case. And then when we have, so for example, here we have the C. So when we build C, we build the klib, static cache, and the framework. Then when we're building the A framework and the dummy framework, we can actually use the C static cache already, so that we are not rebuilding that module, which is speeding up the compilation of A and B. And those static caches, all of them, will speed up the umbrella framework compilation. If your project is complex, and if you work in like a per module or per feature repository setup, this can lead to you just checking out a single repo, making changes in that repo, and everything else is coming already pre-compiled. And you don't have to compile that by yourself. But there's more. to this. We can actually scan the compiled Swift code and see all the symbols from Kotlin that you use. So we know what classes you've actually used. And then we create this used symbols file, which will include them. And the umbrella framework will take those and only include those classes, reducing your total binary size. Because you no longer have to export all of the dependencies and have everything that you don't care about in the final app. Because when everything that's using the KMP is in these packages, the A, B, and C, we know what you need in the final umbrella. With that, let's go to a second demo. It's basically the same demo. Demoing this is weird to me because the way everything is put together is just. But as you can see, KMP A, B, and C, and an umbrella, nothing different. The main difference here comes from how we actually build the frameworks. So if you remember before, we've put the framework declaration or definition directly in the KMP A, B, and C. So this is what built our dummy framework. Now we don't do that. Instead, we have this export project. It's a separate project that imports out the KMP A. And in here, we are building that dummy framework. There is a good reason for it, which I'll get to. We also need something that is very boilerplatey, but this is something that I do use for KMP regularly, because it limits the amount of symbols that you actually make available to the Swift code, where you just declare everything that you want to be available, right? So you manually say, these are the classes that I want to be public and exposed in the framework. And if I add a new class into the KMP-A, it won't be visible unless I specify it here. And then this is coupled with this type aliases file that is renaming them back to the classes we would like. Because the way this exports project is exporting the framework, notice that there is no export anymore for the dependencies. That's because everything we're exporting, we do manually, explicitly say what are the classes that we want to be visible. And because of that, Kotlin native will put these prefixes in. So you probably know them if you ever seen like flows, for example. So you have the com.jet_JetBrains_. We don't want that, so we rename that. And this might seem like so much work to do. But this is something we can generate. This is something we can generate during the compilation of the dummy framework, and you don't have to worry about it. So this is just so that you know how this works, but you wouldn't need to actually write those. So if we go back to Xcode, this time this is the extended approach. Again, you won't see many differences here. We just do import ChatKit, and we have all the same things in here that we had in the previous one. The one difference is that in here we have the unused public class that I mentioned. But if we go to the actual app itself, and I want to reiterate, this is a simulated sample. This is not this is not something that we are generating now. But in the end, you cannot see any of the unused class declarations here in the app because they're not in the umbrella. They're not available to you in the umbrella. All of this can lead to great reductions of binary size, not only because you're not generating all of that Objective-C bridging that is required and is taking a lot of binary, but also because there's no Objective-C headers that would directly call into that code. Any code that's not used anywhere can be eliminated by that code elimination. Because now all of the Kotlin native code, that's static. That's static binary that can be analyzed by that code elimination. For anything Objective-C, anything that's visible, anything that's exposed, that can never be eliminated by the dead code elimination because of the way how Objective-C is inherently dynamic. The way I simulate it here is in the umbrella framework, I have the same exports, and I only say, these are the 3 classes that we actually want to be exposed. But this is what we would get from those used symbols files. So we gather all of them, and we know every single Swift framework uses these classes. And these are the only classes that we need in. And again, with the type aliases, but this would be generated. Now, I mentioned a lot of would be generated and stuff like that, and you wouldn't be writing that. The hope is that you really wouldn't. So I'm working on something that codenamed Kotlin Package Manager. It's something akin to Swift Package Manager, but instead of dealing with Swift stuff, it's dealing with Kotlin Multiplatform integration into iOS. The main idea behind this is it would allow not only this advanced integration that I just described, but also your regular integration. But because you would already be using this Kotlin Package Manager, it would be easier to switch between them or use different things for different repositories. Imagine a future when you can just, next to your iOS code, right? So it's not in your Gradle in the KMP, on the KMP side, but it's where the consumer is where you declare your dependencies. And you can say, I want the modules from this GitHub repository, or I want these Maven coordinates to be put in. That way, you would get the framework, and you would be able to say, this is a dummy framework. This is not the final one. So give me everything that I asked for. And you can use everything. You don't have to worry about going back and making sure things are public or visible. No, everything that you wanted is already visible for that Swift code. And if you don't use it, perfect. It won't be in the final umbrella library because of all of these things in between. That being said, this is a work in progress. I was hoping it would be ready for today. But this is software development, I guess. In closing, before we get to questions, do not use multiple frameworks, except for dummy frameworks. So what I like to say is the difference between the dummy frameworks and multiple frameworks is it's the word use and build. So with the dummy frameworks, you build multiple frameworks, yes, but you don't use multiple frameworks. In the final app, you only have one. Whatever happens during the build process doesn't really matter. We're using the same, the stuff that we're abusing in a way here is what allows libraries to change versions, right? So you could build against one dynamic library, but you don't ship it, and you then run against a different library. That all has to work, and it's the same thing we're using here. And yeah, keep an eye out for Kotlin Package Manager. That's hopefully coming in sometime. So, do we have any questions? Okay. Everyone's too dumbfounded to have the questions, I guess. Thanks, everyone, for your attention, for coming. This has been so much fun working on this, because the way it's integrated is just, as I said, it's weird. When I talk about it, when I tell anyone, all I see are those, what the hell? What is this? But I really do believe, oh, by the way, if you're not using Sky in your KMP yet, make sure you do. I'm going to leave that for a second and go to, please don't forget to vote, follow me, whatever. But yeah, if anyone wants to talk more about this, I'll be available the rest of today. Um, yeah, a lot of people were asking about how to make like more complex integrations where you have different modules, you don't want to see everything, because that's one of the things. Like, it's difficult for me to kind of showcase it in a sample, but you don't see the declarations from the other modules in the native code where you don't want to see them. I have the repo. There was a link down there somewhere. So I have the repo with all of this publicly on GitHub. So you can take a look. You can play around with it, try to break it. I'm sure that there are ways to break it. Yeah. Thanks, everyone.